Hi guys, thank you Phil so much for that particular question. As Phil told you, I'm going to be taking you through another question, and this question comes from Ipileng.
I'm feeling from North Riding Secondary. Please help me with this question.
Hi, thank you so much Ipileng for that particular question. So looking at this particular question, what I'll tell you guys is we're not talking about first principles here. When there's dy over dx, immediately it says to you find the derivative of y in terms of x. So that's what we are saying, and what we are using here is called the rules. So everything you're going to be doing here is based on the rules of calculus. So let's just have a look at it very quick. So the question here says determine dy over dx. And the first question that we are given is y is equal to pi over x plus 3 cube root of x. Now, before we can do anything, we need to first talk about what we are seeing here. The first step at all times when you're doing this particular question is to simplify your question to the simplest form. You must not have x as a denominator of a fraction. You must also not have x as part of a root. So you need to get rid of those and express them in exponential form if possible. So let's just try and see if we can do that. Now, with this one, what I have here is the first thing that I'm going to look at here is I have y is equals to, so to remove the x as the denominator, I'm going to have pi multiplied by x to the exponent of -1. Remember, if it is a denominator and you make it a numerator, you express it with a negative exponent, plus 3 multiplied by x to the exponent of 1. Because it's a cube root there, it's supposed to be 1 over 3. So this is going to be to the exponent of 1 over 3. Now from here, you then say my dy over dx. This is where you introduce your dy over dx. Remember what the rule is, if I must just remind you here. So remember what the rule is. The rule is to say if I have x to the exponent of n, it is going to be n x to the exponent of n minus 1. So it's exponent multiplied by the coefficient, then exponent minus 1. So that's what we are talking about. Now here, this is my exponent. I multiply it with the coefficient that gives me negative pi. X to the exponent of -1 minus 1 will be -2. Then plus, this will give me 1 over 3 multiplied by a 3 will give me a 1. But remember, this is mathematics, so we're not going to represent 1. So x to the exponent of 1 over 3 minus 1 will be equal to a -2 all over 3. And then the other rule that you guys need to know is we don't express the answer as negative exponents. So we need to get rid of negative exponents. Therefore, this is going to be negative pi all divided by x squared. Then plus, what I'm going to have here is 1 divided by x to the exponent of 2 over 3. So this can be my final answer. Now, let's just have a look at what is it that you can also do. By the way, let me just introduce you to something else. So what we can do with this part alone. So what we can do with this part alone is you can always represent it as x to the exponent 1 over 3 multiplied by an exponent of 2. So this, what it means is this will be a cube root all squared. So that's one of the ways that you can introduce this. So it will be a cube root of x. Everything that we have here will be squared. So that's one of the ways that you can represent this particular question. So that's one of the things that you can think about, but what is important is just getting it to this point. Now let's look at the second question. The second question says y is equal to -1 over x plus a root of x. Remember what I said to you guys. You cannot have x as a denominator. You cannot also have x as part of a square root. So I first need to get rid of those things. So this will be y is equals to a -x to the exponent -1. Remember there is a 1 there that we do not represent. then this is plus, the x there will be x to the exponent 1 over 2. This is equals to, what then I'm going to have here is, remember the rule. By the way, let's represent this as dy over dx. Remember what the rule says. Exponent by coefficient, exponent minus 1. Therefore, negative 1 multiplied by negative 1 will give me a positive 1. And then negative 1 minus 1 will then give me a negative 2. Then plus, what I'm going to have here is a half. X to the exponent of half minus 1 will be negative half. But remember again what I said to you guys. I said we do not leave our answer as negative exponents, so we need to express them as positive exponents. To express this as a positive exponent, it will be 1 over x squared, then plus, what I'm going to have here is 1 over 2. Remember this, if it becomes a denominator, it means it will be part of the 2 down there. So this will be x to the exponent of 1 over 2. Now, this can also be simplified to 1 over x squared plus 1 over 2 root of x. Remember, a half means it's a set. So that's what we have there. Now, quickly, guys, let me just recap with what is it that we've been looking at. We said the first thing is always to simplify the question that we have. So simplifying the question means x must not be a denominator. So that's the first thing we always need to do. Also, x must not be in a square root. So those are the two things. Then after getting rid of this, then you can start with your rules. Now guys, remember, what we've just looked at here is using the rules. Last week we were looking at using the first principles, which is the easy version of this, but this is the easiest version of it. Remember what we've been saying, mathematics is food for the soul. So if you do it well, it will nourish every fiber in you. So what I've done today is I've shown you how to actually use the rule. Remember, exponent multiplied by the coefficient, exponent minus 1. And that's all that you need to know about this. Thank you, guys. I will see you just now. We'll have Julian coming through with a wildcard. Then from there, we'll have everything.
It is only through the language of mathematics that we are able to understand the laws that govern the universe. Calculus is the key to interpret the language of mathematics. Calculus was independently developed by Sir Isaac Newton and Gottfried Leibniz in the 17th century. Because neither of them published their work as soon as they discovered their results, there's no clear indication of who discovered calculus first. Through calculus, we are able to study and compare changes of one quantity with respect to another. This has important applications in many sciences, including engineering, biology, chemistry, and physics. The exciting world of robotics would not be possible without calculus. Robots need calculus to carry out complex functions. Self-operating devices known as automata were the earliest forms of robots invented. Complex mechanical devices have been improved on throughout history by many mathematicians, including Gottfried Leibniz. Today, commercial and industrial robots are used extensively in manufacturing, mass production of consumer goods, Earth and space exploration, surgery, and weaponry. In the early 20th century, the idea of a humanoid robot was developed. In 1928, one of the first humanoid robots, Eric, invented by W. H. Richards, was exhibited at the Model Engineers Society in London, where it delivered a speech. The robot could move its hands and head and be controlled through remote control or voice control. Both Eric and his brother, George, which was an improved and updated version of Eric, toured the world in the 1930s. Advancements in the field of maths and science have led to incredible technological development and breakthroughs in the field of robotics. In fact, a bionic man no longer only exists in science fiction movies, but is now a real-life possibility too. Prostheses are devices used to replace a missing or impaired body part, such as a limb. Engineers have developed a next-generation prosthetic, a bionic arm that has 26 joints, can lift up to 20 kilos, and is controlled with a person's mind, just like a regular arm. These mind-controlled prostheses will revolutionize the world as we know it. The amazing innovations of robotics engineering require advanced calculus principles which can only be understood through further study of mathematics, usually at university level.
Hey guys, welcome back. I hope you've been enjoying the show so far. It is time for our wildcard question today. We got it from Monica. Let's have a look at what Monica has to ask us.
Hi Tenfold, my name is Monica. Can you please help me with these questions, 9.2, number 10 and 11? Thank you.
Okay, Monica, I've had a look at this question. I got it down for us so everybody can look at home. This is a really beast of a question, guys. It's based on financial maths. Let's have a look at what the question is. So the question is as follows. Bushra and Philip want to plan to renovate their house. They take out a loan of 55,000 Rand immediately and a second loan of 78,000 2 years later. They plan to repay the loan in 3 equal installments. The first payment must be made after 4 years, and the second installment must follow 3 years later, and the final payment at the end of 10 years. They then give us extra information that says the interest rate is 10.5% per annum for the first 3 years, 10% per annum compounded quarterly for the next 6 years, and 9% compounded half yearly after the last year or for the last year. And they want us to calculate the value of each installment. Okay, guys, so let's have a look at what's happening in this question. We've got 2 people, they took out a loan to renovate their house, and they're going to pay it back, and they pay it back in 3 equal installments after a period of time. And during that time, we have a whole bunch of interest rates that change. So the best way to approach any type of question like this is to draw a timeline for yourself. So I've got a timeline that I've already drawn out for us, and we can just fill in all the information that's there. So the first part that we want to install, what we want to draw in, is to write down what our terms or how long our terms are. So we're going to start by T0 and we're going to end by T10. They tell us that we take out a loan of 55,000 immediately. So I'm going to put this in brackets of 55,000. That gets taken out immediately. And they then tell us in 2 years later, they take out another loan of 78,000. So I'm putting this all in brackets. They then tell us that at T4, we have a payment of unknown value, which we're going to call X. We then pay another installment at T7, which is then also X. And we have a last payment at the end of the term of the same amount, which is also X. Okay guys, so up until now, we've put in all the information of where we make the payments. I put those in brackets that tells us we're taking the money out, and then those that we pay in installments, they're all the equal amounts. So they're all going to have the same value of X, and that's what we want to calculate at the end of the day. Let's fill in the rest of the information that they gave us. So they said for the first 3 years, so that's going to be up until, this is T2, that's going to be T3. For the first 3 years, we have a amount or an interest rate of 10.5%, and that's per annum. There's no compounding period over there. For the next bit, from T3 up until T9, we have an interest rate of, let me just go back up and check quickly, from T3 for the next 6 years, it's going to be 10% per annum, and that is compounded quarterly. Okay guys, so that's compounded quarterly. So what I'm going to do is, I'm going to put there 10%, and because it's compounded quarterly, I'm going to divide that by 4. So I remember that it's compounded quarterly. And then for the last term, I'm going to have 9%, and that is compounded half yearly. So I'm going to divide that by 2. So that's going to be 9% divided by 2. Okay. Hey guys, so that is our timeline. It's all there set out for us. There's no point to now look at the question, go back, because all the information over here is on our timeline. We now need to solve for those values of X. Now, this is the way I'm going to start doing it. I'm going to take each of those values and I'm going to take them to the end of the term. So I'm going to use all my interest rates for those terms and take each of my loans that I take out and bring them to the end of the term T10. And then I'm going to start subtracting those equal amounts. I'm going to show you how that's done. So for our first one, I'm going to take the 55,000 Rand. We're going to take 55,000 and we're going to take that to T10. Now to take that to T10, 55,000 Rand has to go through all of these changes in interest rates until we get to T10. So we're going to write down 55,000 and that's going to go through a process where we're going to have 1 plus 10.5%. And that's going to go for 3 years. So we're going to compound that for 3. We're now at T3. We're now going to take that to T9. So we're going to have 1 plus 10%. But remember, that's compounded quarterly. So we're going to divide that by 4. And remember, if our compounding periods are quarters, we're going to then have to multiply how many compounding periods we have. So from T3 up until T9, we've got 6. So we're going to multiply that by 6. And then lastly, for our last compounding period, we're going to have 1 plus 9%, and that's compounded half yearly for 1 year, and that's going to be 1 times 2. So if I put all of this into my calculator, let's see what we get. So I'm going to put all of this into my calculator. It's going to be 55,000, 1 plus 10%, or I'll lie 10.5%. And that is to the power of 3. And that's going to be multiplied by 1 plus 10% divided by 4 because of our compounding period. And that's going to be to the power of 4 multiplied by 6. And our last compounding period, we're going to have 1 plus 9%. That's going to be divided by 2. And that's going to be to the power of 2 because we have 2 compounding periods in a year if it's compounded half yearly. That gets me a number of 1,573,3027. Okay guys, so what I'm going to do over here, so this is quite helpful for when you go into an exam. All of these values that I'm going to work out, these numbers are quite large. So what we can do is we can use a function on our calculator that stores these values for us, and therefore we can use them afterwards later on in the calculation. So let's go to the next part. I'm not going to store this value yet. I'm going to take the next part, which is 78,000, and I'm going to bring that to term 10. So if I take 78,000 and I bring that to term 10, I'm going to have 1 plus my first compounding period is going to be at 10.5%. 10.5% to the power of 1 because I'm only going 1 year. So I'm going from T2 to T3, so that'll only be 1 year. And then I'm going to have all the other things that I had before for the 55,000. So that'll be 4 times 6, and that'll be 1 plus 9% divided by 2 to the power 2. And I'm going to find out what that equals. So what I'm going to do is I'm just going to change a few values in my calculator. I'm going to make this 78,000. And I know that all the other remains the same except for this last value, or this exponent over here is going to become 1. And I get a value of 170,240 and a whole bunch of decimal places. So that's 170,240,2432. Okay, guys, so we're on track now. I told you this is a monster of a question. The next thing that we're going to do is we're going to take all our X, or all our payments, and we're going to take them through to term 10. So let's have a look at our first payment. So our first payment, we're going to take through to term 10. I'm going to take that through to term 10. And we have our first payment when we have an interest rate of 10% compounded quarterly. So we're going to have 1 plus 10%. That's going to be compounded quarterly. And that's going to be to the power of 4 times 5 because we're doing it for 5 years. Then we're going to have the last compounding period of 1 plus 9% divided by 2, and that's for another 2 years. And that's going to get me some value equal, well, multiplied by x. Let's have a look at what that's going to be. So if I take this, I'm going to clear that. We're not going to need those for now. I'm going to have 1 plus 10% divided by 4. That's all going to be to the power of 4 multiplied by 5. And that's going to be 1 plus 9% divided by 2. And that's all going to be raised to the exponent of 2. So that gets me this value over here. Okay guys, so what I want to mention over here to you now quickly. I've got this value in my calculator. I'm going to use it over and over again. What I'm going to do is I'm going to store it as a variable in the calculator, and when I keep on using it, I'm just going to then replace it with that variable. So what I'm going to do, let's have a look on the calculator what I do to store this variable. I've got this value. I'm then going to press my shift key, my store key STO, and I'm going to store it as a value of A. So what that means is every time I then press A, I'm then going to get the value which I'm looking for. And that's going to be the following. So it's going to be 1,789,410,118x. I want to try and keep all these decimal places that my calculation is accurate at the end of the day. Let's have a look at the second payment. So if I take the second payment and bring it to T10, I'm going to have x multiplied by, let's have a look where my second payment is. It's T7. I want to take that to T9. So I've got T7. I'm going to have then my second payment 1 plus 10% divided by 4. And I'm taking that for another 2 years. So it's going to be 4 times 2. And then my last compounding period, which will be 9% for 2. And that's going to give me another same value for x. So again, I'm going to go to my calculator and see what that is. Now I'm a little bit lazy, but this calculator is very awesome, guys. So we can actually go back and just change a couple of values that we need to be changing. And that 5 then becomes 2. So I'm left with then this value over here, and I'm going to do the same thing. I'm going to store it as B. So whenever time I put in B, I'm going to get this value. And that value is 1,330,526,426. or 424, and that's going to be x. Okay, so I'm just going to make a quick note of what I did over here. I stored this value as A, and I stored this value of B. Okay, so that's all our stuff laid out for us over here. Okay guys, so what I've done at the moment, I've laid out all my information that I've been given in the question. I've taken all my payments and all the loans that I've taken out, I've brought it to term 10. Now, because I've made payments throughout that, if I add up all these little bits of information that I've just worked out with my interest rates, that must then give me a value equal to 0. And if I then add all of them up, if I add up this value over here, and I add up this value, and my values that I've stored for A and B, plus, remember my last payment that I'm going to be making. If I add all of that up, it must then get me a value of 0, and that will tell me that my loan's paid off. So if I do that, these two values added up, I'm just going to add them up quickly using the calculator. I'm then going to have 146,573.3027. I'm keeping all my decimal places for accuracy, plus 170,240.2432, and that gets me a value of 316,813. So if I write that down, it gets me a value of 316,813, 5459. Now if I have to add up my payments, I'm going to add AX plus BX plus my last payment of X. And like I said, this must all give me a value of 0 at the end of the day to show that I've paid off my loan. So now solving for this, I'm going to actually add up my A, my B, and my C on my calculator. So I'm going to have alpha A plus alpha B plus 1, which is my value over here. It's going to be plus 1. And that gets me this value over here. Now I'm going to do another store. I'm going to store it as C. So whenever I press C, I'm going to end up with this value. So I'm then going to have this value 316,813,5459, and that's going to be equal to, now I just wrote down that this over here is equal to C. If I bring this to the other side, I'm going to have negative cx. And if I want to solve for x, I'm going to take all of this and divide it by c. That then ends up with the value. Therefore, I can say that x is going to be equal to, now let me go back to my calculator here quickly. I'm going to take my value that I've just found, I'm going to press equals, and I'm going to take this value and divide that by my value of c. And that gets me a value of 76,897. 76,897. Now this is where I can actually round off. I'm going to round it to 2 decimal places. It's going to be 676. So that's gives me 68. And we're working with money, so that's going to give me rands. Okay, guys. So like I said, this is a beast of a question. It really is a monster question. But remember, you got all this information. If you can get this down on a timeline and you can then solve out each piece, think logically of how you're going to start paying off this loan by bringing all your payments to the end and subtracting your values of x. We then find our final value to be that. You can actually go back and check this. We don't have time for that now. But if you take all of these and you plug these values back in a logical order based on your timeline, you should end up with a value of exactly 0. Remember, at the end of the day, we round off to 2 decimal places because we're working with money. Hey guys, that's all we're going to do now for the wildcard. We're going to take a quick break and then we'll be back answering some more questions. Thanks, guys.